In this lecture, we will look into Hadoop. Hadoop is an open source version of Google's MapReduce. MapReduce is the technology that was used in the Google search window. And since we've all used it before, we know how powerful it is. Currently, it is an open source version software that is in the Yahoo's Apache group. Hadoop is the name of a yellow elephant toy. That's why we have that logo down there, which is owned by the son of the creator of the Hadoop group, which was Dog Cutting, who decided to use this name because it was meaningless, it was easy to spell and pronounce. In addition, it was not used elsewhere. These are some other Hadoop-related systems that eventually you'll hear about, so let's get some relations to them. HBase is a Java-based open-source, non-relational, distributed database developed as a part of the Apache Hadoop project. HBase was modeled based on Google's Bigtable and runs on HDFS, which is the Hadoop distributed file system, to enable fault-tolerant storing of large quantities of sparse data. Apache Flume provides services to efficiently collect, aggregate, and move large amounts of log data in a reliable distributed way. Flume uses a simple and flexible data flow streaming mechanism that is fault-tolerant by using tunable reliability mechanisms and recovery schemes. The word flume means a human-made channel of water, which refers to flexible data flow streaming features of Flume. They make human-made channels of water in order to move logs when there is no natural flow of water. And that's where the name Flume came about. In addition, there is Apache Mahout, which provides free implementations of distributed and scalable machine learning algorithms that can provide collaborative filtering, clustering, and classification data, and also provides Java libraries for common math operations. So Hadoop has support of Apache Mahout, which basically can support machine learning, artificial intelligence technology. The word Mahout means elephant rider, and that's where that logo comes from. A rider is on a yellow elephant. And this means a trainer or keeper. And this is related, of course, to the Hadoop name. Then there's Hive. This was developed by Facebook to enable its programmers, among the programmers who are not really Java programming experts, to easily write query codes in SQL to emulate on-demand SQL operations on Hadoop. Very soon I will talk about Hadoop and also SQL in further details, so just wait a little bit. Hadoop, storage, access, analysis of data sets. This is the main focus. Hard drive storage capacity has tremendously increased. But the data read and write speeds to and from the hard drives have not significantly improved yet. Simultaneous parallel reads and writes of data with multiple hard disks require advanced technology, and that is where Hadoop comes in to be extremely effective. Challenge 1, hardware failure. When using many computers for data storage and analysis, the probability that one computer will fail is very high. I'm going to say that when I say many computers, I'm looking at hundreds, thousands of computers, maybe tens of thousands of computers in a parallel distributed fashion where the way I control them and manage them are in big clusters. So when I say many computers, I really mean many. Next is cost. To avoid data loss or computed analysis information loss, using backup computers and memory is needed, which helps the reliability but is very, very expensive. Then we have challenge 3, which is combining analyzed data. Combining the analyzed data is very, very difficult. In one part of the analyzed data, if it's not ready, then the overall combining process will need to wait until that part is actually done. And that will create a delay. In addition, if one part has errors, what are you going to do? And if you combine them, what will happen to the final combined result? How faulty will it be? These are all serious issues. Hadoop is a reliable, shared storage and analysis system. It is a combination of HDFS, which is the Hadoop distributed file system, and MapReduce, which is a combination of a map function and a reduce function. When I say HDFS, Hadoop distributed file system, evidently the DFS, the distributed file system, is on there. It is a designed system used for storage management based on a network of computers. It is optimized to store huge files with streaming data access patterns. It is designed to run on a cluster of general computers, commodity server systems. HDFS was designed to be optimal in its performance based on a warm pattern. This is a write once and read many times pattern, which is an efficient data processing pattern. Soon you'll see that we will put it in there as the data comes in. Just store it as it is. And then every time we have a query, we want to extract some type of information or statistics out of this data, we will read it and read it and read it again. This is what I mean by warm. Write once and read many times. HDFS was designed considering the time to read the whole data set to be more important than the required time to read the first record. Files in HDFS are divided into block-sized chunks. A 64 megabyte default block size is the size that is used. It is the minimum size of data that can be used to read or write. And it simplifies the storage and replication process. It provides fault tolerance and also speed enhancement for larger files. The default replication factor in Hadoop is 3. And I will talk more about this, including an example, very soon. HDFS clusters use two types of nodes. One is the master node, which is called the name node. The other one is the worker node that actually does the work, which is called the data node. The name node is in charge of the file system namespace. It maintains the file system tree and the metadata for all the files and directories in the tree. It stores the local disk using two file formats. One is the namespace image and the edit log. These two need to be protected and recorded well. Data nodes. This is the workhorse of the file system. It is used to store and retrieve blocks, which are the default size of 64 megabytes, when requested by the client or the name node. Then, it needs to report back to the name node periodically with lists of blocks that were stored. Data nodes send heartbeat signals to the name node every 3 seconds to ensure connection and to report operation status. MapReduce is a program that abstracts the analyst problem from stored data. MapReduce transforms the analysis problem into a computational process that uses a set of keys and values. Keys and values. MapReduce was designed for tasks that consume several minutes or hours. Also, it processes data on a set of dedicated, trusted computers connected with a high-speed network. In addition, it is managed by a single master data center. MapReduce uses a somewhat brute force data analysis approach. The entire data set, or a big part of the data set, is processed every query. This is what we mean by brute force. It is a batch query processor model. It saves it in a batch, and then this is overall analyzed every time a query is requested. MapReduce enables the ability to run an ad hoc query against the whole data set within a scalable time. So that is why it is so powerful. You will not just use sample data, you will search across the overall data set. Many distributed systems combine data from multiple sources, which is very difficult. But MapReduce does this in a very effective and efficient way. Technical terms used in MapReduce. We'll first look into seek time. Seek time is the delay in finding a file. Transfer rate is the speed to move a file. Transfer rate has improved significantly more. And this means that the networking equipment and the networks that support this have much more bandwidth, much higher throughput, and are much faster and much more reliable. On the other hand, we have seen very little improvement in the seek time. So still the seek time within a database is still relatively slow. Looking at what we have as an advantage in transfer rate and as still a disadvantage in seek time, Hadoop system was maximized in its performance considering these two factors. MapReduce gains performance enhancements through optimal balancing of seeking and transfer operations. Reduce seek operations, effectively use transfer operations more to gain a higher performance. In the next lecture, we will compare MapReduce with traditional RDBMS, Relational Database Management Systems. These are the references that I use, and I recommend them to you. Thank you.